Good morning, and thank you, Joe, for this nice introduction. So one of the themes in this conference today is innovation. So how many innovators we have in the room? How many people are nurturing ideas in their team, organization, or product? Few people. So for the others, what stops you? Or for the ones who raise their hand, what's hard with innovation? Any ideas? Anyone wants to shout? Not reaction, so others, how others will react, what they will think about our ideas. Yeah, anything else? Feasibility. People buying, so a lot about others, how others will react about our ideas. So I will touch a little bit about others today. What I'm really interested is you. My hypothesis today is that also what stops us is our brain. Some of the cognitive process happening in our brain stopping us from innovating. Other question for you. Do you think some of the problem is also that we lack ideas? Hint, Jeff Patton told you the answer yesterday. No, we don't like ideas. We have lots of ideas, but we don't know which one is the correct one, how to pick the good one. Yeah. So just, even if Jeff told us we have many ideas, I just want to convince you today and digress a bit and talk about this thing which is on the stage that you can see here, this light bulb. We use this light bulb to represent ideas and innovation more and more. But do you know who invented it? Who had this bright idea of making a light bulb? No one? Edison? Was it Edison? Tesla? Not sure? Okay, so let's look at history. In 1802, Humphrey Davy demonstrates an incandescent light. So how does a light bulb work? You have this small metallic piece in the middle, which you call a filament. You make an electric current go through it, produces heat, and that heat produces the light. That's one of the first concepts for a light bulb. The second important concept is the bulb itself. Why? Because when this filament is in contact with the air, it might break easily. So having a bulb which creates a near vacuum helps the light bulb to stay longer, to not break that easily. Edison was born in 1847. So two of the main ideas that have been used to create a light bulb were there even before Edison was born. And it doesn't stop there. In 1860s, Joseph Swan, a Brit, created the first working prototype of the light bulb. He even patented it. Edison was 13 years old. Edison started to work on a light bulb in 1878. So why do we associate Edison so much with the light bulb? We have this idea, we know that Edison is a great inventor, we know he has invented a lot of things. We know he's associated somehow with the light bulb, we've heard it, and we're making a story in the middle. We're jumping to conclusion. Edison has invented the light bulb. There is cognitive bias behind that. I actually don't want to talk about those today. There's too many to cover them all in 45 minutes. What's interesting about Edison and the way he innovated is that he didn't start with an idea. He started with a goal. He wanted to deliver an outcome. What he wanted was to bring lights in every household in America. He wanted to start with Manhattan first, 3 blocks, then the whole of Manhattan, and then every household in America. Then he gathered ideas, and he experimented a lot. And as he says himself, he used ideas of others. He's still a very creative person, but many times he borrowed ideas wherever he could find them. Which leads me to one good news today, is that Jeff Patton told you, ideas is everywhere. We have a lot of them. You don't need to be creative to innovate. You're here at a conference, you have listening to many speakers who will give you a lot of bright ideas. You can use those. Bringing those into your organization is also innovation. You don't need to create something new. You can if you want, but you don't have to. The bad news, though, is that once you have those ideas, then the hard part starts, the hard work you have to put. Edison worked day and night in innovating to create the light bulb, or not create, but to improve on the design. The first hard work you have to do is collecting those ideas. Call them catching them. And one problem with your brain is that we tend to think that our brain can remember things pretty easily. The reality is that most of the ideas you hear today, by tomorrow or the day after tomorrow, you will have forgotten them. This is not so much because our brain cannot remember, this is how our brain remembers. We store information, strangely enough, by retrieving it. The more we retrieve some piece of information, the more we remember it. So unless you talk with your colleagues and friends about the ideas you're hearing today, you won't remember them so vividly. So my advice to you is the best way to catch those ideas is pen and paper. Note them down. Once you've noted all those ideas, you went to this great Agile New Zealand, you come back to work, you have many of them. Which one do you choose? Which one is the good idea? And is that a rational decision? Do we make that a rational choice? Shane is waving his head, no. How many of you are married or have a partner? Was that a rational choice? You made an Excel spreadsheet with the list of characteristics from your potential mate and then had a weighted average, a small algorithm, and yeah, that's this person? No? I tried, but didn't work out. So when we are making those life-changing decisions, we are irrational, and everyone agrees with that. So when we are making those choices of which idea we have to bring in our team, in our organization, are we rational at that time? Are we rational when we are taking decisions which impact us a little bit, and irrational when we are taking decisions which change our life? That sounds strange. So let's look into our brain, into cognitive psychology and what it can tell us. So this is a talk about the brain, so I will ask your participation a lot, or the participation of your brain. Are you ready? Half. Okay. First question. What can you tell me about this picture? What are those people doing? What emotion you can see here? Angry. Do you agree? They're angry people? Playful? I would still go with angry, but... How did you come up to that conclusion? That they were either angry or playful? Their face? So you look at facial expressions? Yeah? How did you recognize that facial expression? Did you went through a database of facial expression in your memory? You look, no, yeah, this one? Doesn't look like that. Can you explain this process? Doesn't look like you can. Okay, something maybe a bit easier that you will manage to explain. 17 times 240. This is a talk about your brain, not about your pocket computer, by the way. So, anyone wants to give a shot? No, we're too tired in the morning? 4,080. Did you see the difference on how your brain reacted to those two problems? Was not the same thing happening? Let's try to list it. So the first one, the image, seems that it was completely automatic, non-conscious. You were not able to tell me how you were recognizing that facial expression. Associative, you associated the facial expression with an emotion quite quickly. The second one, the multiplication. I guess something was going on in your head. Maybe you tried to do 20 times 240 and it's 4,800, and then maybe you tried to do 3 by 17, or I don't remember. My brain cannot process that much. But it was conscious, right? You were totally in control of what you were doing when you were trying to solve that problem. Everyone agree with that? Cool. First one, you were extremely fast. Just in 1 second, you told me this is anger or this is playfulness. You recognized something very quickly. And you didn't seem to break a sweat. It was very easy for you. Second one, you were slow. I would be slow too, don't worry. And as I guess, it put a lot of cognitive strain in your brain. You had to think a lot, and that was quite difficult. So those two modes of working for your brain, cognitive psychologists call that system 1 and system 2. So system 1 is this automatic system, which is fast, non-conscious. We, in general, associate it with emotions. The second system, system 2, very controlled, very slow and high effort, in general associated with more logical reasoning. And cognitive psychologists come with this two-system theory. It's a model, so it's way more complex, but to try to explain it in a much easier way, they come with this model of two systems. Daniel Kahneman, in his book, Thinking Fast and Slow, so the fast and slow thinking is about those two systems. If you want one reference, one book about cognitive biases, this is the book you want to read. Daniel Kahneman is a cognitive psychologist and came with that theory. So what's in it, he describes what's a cognitive bias. Basically, a cognitive bias is a systematic error of judgment. The theory is that your system 1 is the one who is making decision. It's the one in charge. Your system 2, Kahneman calls it the lazy controller. Why? Because it's slow and high effort, and your brain is not tailored for high effort. It's trying to minimize the amount of resources it spends. So more often than we would like to, system 1 takes a decision, and system 2, who should control and say, whoa, this is not rational, we're just not using it. Which makes that we're all affected, all of you, me included, everyone in this planet is affected by those biases. Because they come from built-in mechanism. Again, it's the way system 1 works. The way system 1 takes decision to be fast is that it's using shortcuts. It's using tricks. Call them heuristics. This is a very important mechanism. Don't think that your brain is flawed and that we have evolved something which doesn't make sense. No. This helped us a lot thousands of years ago when we were still living in the caves, and still help us every day. When you are driving a car and someone jumps in front of you, you don't want to involve a very slow logical reasoning to take the decision if you want to brake or not. Just want it to happen right away. So what are those mechanisms, those heuristics? Let me show you. More problems for you. I will give you two sets of letters, and what I want you to look is with which sets of letters you can construct a larger number of words in English. Ready? Go. 2. Everyone agrees with 2? There's no trick, don't worry. 2. But how did you come up with that solution? Did you build all the words you could build? You built a few one? 3 vowels. So you decided that there's more vowels in the second one, so it must be that? Yeah? Same strategy here. So basically what I think you used is one of these two heuristics, availability or substitution. Availability is you try to build up a couple of words. With the first set, you found on. With the second set, maybe you found cat, trap, tap. There was a few words, 3, 4 letters words that you can build, and you stop there. Say, I have 4 words available in my memory with the second set, that's enough. I take the decision. The second heuristic, substitution, is what you guys have used. It's basically, instead of answering this difficult question of which sets, with which sets you can build a larger amount of words, you answered another question, which is, with which sets of letters contains letters which are the most frequent in the English language. And you had the hypothesis that those 2 questions are equivalent. That's your system 1 working, and that gives you the correct solution. The trick here is, did you notice what you were doing? Yes? I guess you noticed because we took the time to think about it. But when you were doing it, I don't think you noticed, because what's happening here is, again, your system 1, which is automatic and unconscious, is doing that. But I ask you to stop and think, and then you said, oh yeah, now I understand what I'm doing. Okay? So, what cognitive psychologists tell us is summarized in this sentence from Antonio Damasio, that system 1 is taking the decision, he is the kind of center of emotion, so we are not thinking machine that feel, but rather we are feeling machine that think. What I like about this quote is not only the quote, but who is giving that quote. Antonio Damasio is not a cognitive psychologist. Antonio Damasio is a neuroscientist. And he did different experiments with patients which have impaired ability of expressing emotions. They have brain damage. And what he found out is that those people, they are completely fine, they are very clever, they can solve mathematical problems, they have absolutely no impaired intelligence, but they are totally unable to take any kind of decision. So same conclusion coming from 2 fields, that decision seems to come from something automatic, something non-conscious, some emotions. So how do we tie that back to innovation? Did it ever happen to you that you struggle with one of your ideas? Or you heard a great idea, but you're like, I'm not sure? Yes? So my guess is that what's happening is a first cognitive bias today, the mere exposure effect. We have the tendency to like things just because they are familiar. This is what advertising is all about. Nowadays in advertising, you don't necessarily present your product or tell why it's great. You just put the brand on stage and you hope that everyone will notice it and start to like it. This is also, if you ask me, one of the reasons some politician gets elected, so no one thinks they can, just by saying crazy thing and getting more airing time. We see them more often, we start to like them. What's happening here is, again, this availability heuristic I told you about. Basically, when you hear new ideas, when you want to implement that ideas in your organization, what your brain is doing is it's looking in memory. Have I seen that before? If I've seen that before, then it's probably good. If I've never seen it before, it's potentially dangerous. Could kill us. Your brain doesn't like to take such risks. So in doubt, your brain will not like new ideas, will fight them, even if they are your own. So that's one of the reasons why others struggle with your ideas. It's not because it's a good idea or a bad idea, it's just because they've never seen it before. So if you want one trick, that's the only trick I can give you about others, is just continue talking about your ideas. Because the mere exposure effect will kick in after a while. And if you can find people who actually like your ideas, ask them to talk about it. The more people will be exposed for that idea from different directions, the more they will like it. But what I want you to not forget is that you too are affected by this mere exposure effect. And that when you're trying to innovate in your team or in your company, the first person you have to convince is yourself. In their book, Fearless Change, Marilyn Mance and Linda Rising list a bunch of patterns for organizational change. And one of the first patterns they talk about, and they say is one of the most important to use at the beginning, they call that evangelist. Someone who believes in the idea. The first thing you have to do is to believe in the ideas. Try them at least. Because you don't know if it's good or bad. It's just your brain first reaction. I've never seen that before. Therefore, I don't want it. The ways they found out this mere exposure effect is kind of funny. It's, there's many experiments cognitive psychologists did, and they are kind of funny bunch of people. They always find funny experiments. One of the teacher, what he did, he asked one of his students to come in the class fully covered with a black bag, without any kind of explanation. The students, when they saw that, they were like, whoa, what's happening? We don't like that person covered from top to bottom with a black bag. We can't see him, don't like him. They repeated this experiment over and over. The student continued to come, and after a while, the student liked him. Nothing had changed, they didn't have any new information. Just same thing, this mere exposure effect kicking in and saying, I've seen it often, so it's normal. Kind of strange. So you need to be passionate. You need to have passion for your ideas, else people won't believe in them. However, there's a catch, sorry. But when you start to be too passionate, there's another cognitive bias that comes in called the sunk cost fallacy. This bias is a tendency we have to take decisions based on previous cost or time invested. So let me try to illustrate that. Imagine for a second that you're really into skiing. You're booking ski trip as much and as often as you can. You do that so much that you didn't realize that 2 of those ski trips will be on the same weekend. You've paid for them, you can't get refunded. The money is gone. The first one costed $400, the second one $200. You know for sure, don't ask me how, but you know for sure that you will enjoy the second one much more. That's a given. You have some information, you look at the forecast or whatever. Oops. Which one do you go to? Second? You sure? What was your first intuition?
We want to say second because we know that it is the first one now. You want to be right.
Yeah, because we want to be right. I went too fast. So they gave that question, they gave this thing to many people. This is a scientific research, actually. What they found out is that many people still choose to go to the first one. You see that this is completely illogical. The ski trip, whatever your decision, is $600. If you go to the first one or the second one, the cost is the same. So you should not look at the cost when you're making the decision. The problem is our system one do not like to lose. Losses weigh heavier than gain. This is also why, parenthesis, why change is so difficult, is because we weigh losses much more heavily than gain. So people still try to go to the first one. This effect is amplified if you have responsibility in that choice. So if you're a manager who is responsible for all the cost or time invested in an idea, this effect is much stronger on you. When we are pushing ideas forward, sometimes we just do it because of the time we've invested, because of the money spent. Again, this is not logical, and this is why sometimes you see companies pouring millions of dollars in ideas that they saw were not going anywhere. Just we've invested so much. We need to continue investing. We need to continue pushing. So you need to be passionate about your ideas. You really need to believe in them. But what I want to tell you also is you need to be ready to pivot. You need to be ready to teach the idea because you see it's not working. The best way to do that, and maybe you see where I'm going, is to measure something towards your goal or your outcome. Because again, your brain in general will not like to do this decision rationally. It will say, no, I spent so much time and effort, let me continue, let me push forward. So don't be afraid to pivot and change ideas. How are we doing? Is everything okay? Am I saying anything surprising? Does it confirm what you already knew? Yeah? You knew some of that stuff? Yeah? Awesome. So, third bias today, confirmation bias. Well, one of my guesses is that some of you came to this talk because when you read the abstract, you found something you liked. You found something that was confirming your existing belief and said, okay, I'll go listen to this strange French guy and be sure that what I know is correct. This confirmation bias is the tendency we have to search for ideas and information that validate our existing beliefs. So let me try another experiment today. Let's hope this one will work. I'll give you, right now, 3 series of numbers. Ready? It's no trick yet. 2, 4, 6, 10, 12, 14, and 22, 24, 26. Those 3 series of numbers, they follow a rule I have selected. You don't know it, I know it. What I want you to do is to give me more series of numbers, and I will tell you if they match my rule or not. And I want you, through that exercise, to guess what the rule is. Anyone? 32, 34, 36. Yeah, match my rule. 30, 32, 34. Yeah, match my rule. 37, 27, 29, 31. Yeah, match my rule. Okay. Have you guessed my rule? 3 numbers. Group of 3 numbers. Everyone agrees? You all gave me series which was +2 all the time. Well, my rule is any 3 numbers in ascending order. Sorry. I used another cognitive bias in this exercise, is that you were primed by the 3 series you saw. What you did is you formed an original belief, an initial belief that the rule must be +2. You had initial intuition from your system 1, the rule is +2. But the trick here is that you never try to disprove that belief. All the series you gave me were trying to confirm that belief that the rule is +2. Never did any negative testing here. And that's what this confirmation bias is about, is we tend to, our first reaction, maybe we'll see our users having some kind of behavior, we will form quickly an initial belief, and most of what we'll build in our product is just to confirm that belief. We, in general, or rarely try to build something small to prove that we are wrong. So we need to keep an open mind. When we're innovating, with all those ideas we have, do not try only the ideas that confirm what you already believe in. We need to be able to try ideas which goes in the other direction, just to be sure. Great. I shown you 3 bias. I touched a little bit about some other bias during that talk. There is many more of those bias out there. Wikipedia, the ultimate source of knowledge on that planet, lists at least more than 100. Many cognitive psychologists list around 100 and more. It's growing. So what can we do about it? I told you about 3 of those bias. Now you know 3 of them. Will that help you? Will you be able to fight those biases now? Yeah? No, probably not. The fact is that those biases are still coming from your system 1. It's still automatic. You still don't control it. Even if you know about them, you still have this system 1 giving those reactions. So actually thinking that you can fight cognitive bias by knowing them is in itself a cognitive bias. Yeah, I know. So one way we can do that is remember this system 2, the lazy controller. Well, you've seen a couple of times when we started to reflect about the heuristics or about the ski trip, we managed to find the correct solution. But we needed to pause, take the time to think about the decision we are making. So one way we can fight them is to actively engage with system 2. Remember, the system 2 is slow and uses a lot of energy. That means we need to deliberately allocate time for thinking. We need to make that place in our calendar. We need to be able, when we are at work, when we are pushing ideas, to ask ourselves, am I rejecting an idea just because I've never seen it before? Am I pushing ideas just because I spend so much time and money and I just don't want to let go? Am I only trying ideas that confirm my beliefs? If you don't take the time to ask those questions, your system 1 won't ask them. So we need to stop doing and start thinking. Well, I'm being a bit extreme here. You still need to do something at some point. My point is, if I look at how I work, and maybe you do differently, but I do a lot. Every day at work, I go do workshop, facilitate retrospective, go talk to people. I constantly do, but I don't have a place in my calendar where I can say, no, now I'm not doing, I'm thinking about what I'm doing and why I'm doing it, and am I taking the correct decision? Am I driven by biases, or am I really being reasonable? Edison had another trick to innovate, which for me is his greatest invention. He called that Menlo Park. Have you heard about that? So Menlo Park is the laboratory of Edison, basically. What Edison did is he dedicated a place to innovation. He built a laboratory, hired a lot of people, and in that lab, they experimented. He basically created the first culture of innovation. They tried everything they could. When they were working on the light bulb, the story or the legend says that they even tried as a filament the hair of from the beard of a red man. That's kind of strange. Basically, they tried everything that was not backed up by science. If they had hard scientific data, they would not try it. If not, they would just experiment. Who knows? Maybe it will work. So I'm going to wrap up a bit early. My recipe, or my 2-cent recipe for innovation. First thing is start with a goal. We talked a lot about outcome in that conference. What are you trying to accomplish? Why are you innovating in the first place? Catch some ideas, note them down, pen and paper. This is the best way to gather them. Believe in them. I want to say build them. try them at least. Be ready to pivot. So again, the best way is to measure something, have data. Keep an open mind, try things that you haven't tried before. Keep thinking. Does that sound familiar? Is it new? I think this is not new. I think I have not invented anything. I feel when I did this, when I prepped this talk, I didn't thought I would end up here, but when I wrote this slide, the first thing that came to my mind was like, oh, this is Lean Startup. What have I done? And actually, I'll give you another trick. Because of that, it's very easy to disprove what I've just said. I like Lean Startup. I really like the build, measure, learn. So you could argue that this whole talk is my own confirmation bias. And you could be right. So keep thinking and keep experimenting. We are not rational creatures. This is just the way we are. So when we have those thousands of ideas, knowing which one is good and which one is bad, we actually can't do it. We need to try them. We need to divide experiment and see which one are working, and of course, trying the smallest experiment possible. If you want to go further, this is some of the science I've used in that talk. The first one is one of the first scientific paper on cognitive bias. The second one is this paper from the neuroscientist on emotions driving our decision. And the three others are the three cognitive bias I've shown you today. Thank you.